Yes, welcome back. Let us discuss fourth example. Find z inverse of z square plus z divided by z minus 1 whole square. Let us find inverse z transform of this expression. Solution: let f of z is equals to z square plus z divided by z minus 1 whole square. Here in numerator you take z as common, then you are getting f of z is equals to z into z plus 1 divided by z minus 1 whole square. This z you send it to LHS side, it becomes f of z by z is equals to z plus 1 divided by z minus 1 whole square. Now let us go with partial fraction. Here f of z by z is equals to z plus 1 by z minus 1 whole square. If you apply partial fraction for this, you are getting a by z minus 1 plus b by z minus 1 whole square. You take it as equation 1, and here LCM is z minus 1 whole square. If you multiply both sides, you are getting in numerator z plus 1 is equals to a into 1 z minus 1 cancels, you are getting a into z minus 1 plus b. Here denominator z minus 1 whole square and z minus 1 whole square gets cancels, you are getting b only. Then if you solve this, z plus 1 is equals to az minus a plus b. Comparing like terms, you are getting directly here coefficient of z is a, here coefficient of z is 1, therefore a value is 1, and here constant terms are minus a plus b is equals to 1, here constant term is 1, therefore if you use a value here, you are getting b value directly, b value is 2, a value is 1 and b value is 2. Use a and b values in equation 1, therefore your equation 1 becomes f of z by z is equals to a value is 1, 1 by z minus 1 plus b value is 2, 2 divided by z minus 2 whole square. And here z you send it to RHS side, it becomes f of z is equals to z by z minus 1 plus 2z by z minus 1 whole square. Now you apply inverse z transform on both sides, it becomes z inverse of f of z is equals to z inverse of z by z minus 1 plus 2, you take it outside, z inverse of z by z minus 1 whole square. Now use the formulas. Here f of inverse z transform of f of z is f of n, and inverse z transform of z by z minus 1 is 1 by using this formula. The same way here 2 as it is, inverse z transform of z by z minus 1 whole square gives z of n. So that is if you send this z into RHS side, it becomes z inverse of z by z minus 1 whole square is n. Therefore here the inverse z transform of this second term is n. So the final inverse z transform value for the given expression is f of n is equals to 1 plus 2n. So for that you need to thorough with these basic formulas always. Many times in many example we are using these basic formulas. So mainly here you need to learn many more formulas to find inverse z transform. What is inverse z transform of z of 1, z of n, z of a power n. So many formulas, many basic formulas you need to learn, so to get inverse z transforms. Okay, please keep watching. Now let us proceed with fifth problem. Fifth problem is find the inverse z transform of 3z square plus z divided by 5z minus 1 into 5z plus 2. Here let us find the inverse z transform. Solution: let f of z is equals to 3z square plus 3z square plus z divided by 5z minus 1 into 5z plus 2. Here in numerator you take z as common, then you are getting z into 3z plus 1 divided by 5z minus 1 into 5z plus 2. This z you send it to RHS side, it becomes f of z by z is equals to 3z plus 1 divided by 5z minus 1 into 5z plus 2. Now you apply partial fraction on RHS term, you are getting a divided by 5z minus 1 plus b divided by 5z plus 2. You take it as equation 1. Now let us find the values of a and b here. Here LCM is 5z minus 1 into 5z plus 2. If you multiply both sides, you are getting 3z plus 1 is equals to a into phi z plus 2 plus b into phi z minus 1. Then in next step 3z plus 1 is equals to, if you multiply with a, 5az plus 2a plus 5bz minus b. Comparing like terms, we can write here coefficient of z is 5a, here coefficient of z is 5b. 5a plus 5b is equals to, here coefficient of z is 3, we equate it to 3. This is your equation 2. Then you write constant terms, 2a minus b is equals to 1. So solve equation 2 and 3. Here while solving I am multiplying equation 2 with 2 and equation 3 with 5. Therefore your equation 2 becomes 2 into equation 2 gives 10a plus 10b is equals to 6, and you are multiplying 5 to the equation 3, then you are getting 10a minus 5b is equals to 5. Here if you subtract, you are changing the sign while subtracting, then plus 10a minus 10a gets cancels, plus 10b plus 5b gives 15b, 6 minus 5 gives 1. Therefore your b value is 1 by 5, sorry, your b value is 1 by 15. Then you take equation 2, substitute b value here. Equation 2 is 5a plus 5b is equals to 3. 5a is equals to 3 minus 5b. Here if you use b value, then you are getting your final a value becomes a is equals to 8 by 15. B value is 1 by 15, a value is 8 by 15. Use these a and b values in equation 1. Then your equation 1 becomes f of z by z is equals to 8 by 15 into 1 by phi z minus 1 plus 1 by 15 into 1 by phi z plus 2. Now here you need to rewrite this step. Left hand side f of z by z as it is, and RHS term 8 by 15 as it is. Here numerator 1 as it is, denominator. While writing this denominator term, I am taking here 5 outside, that is 5 common. Then you are getting z minus 1 by 5 plus 1 by 15 as it is. Again here in denominator I will take 5 outside, then you are getting z plus 2 by 5. Now you apply before going to the inverse z transform, you simplify this step. F of z by z as it is, 8 by 15, sorry, here 15 into 5 gives 75, 8 by 75, 1 divided by z minus 1 by 5 value is 0.2 plus 15 into 5 gives 75, 1 by 75 into 1 divided by z plus 2 by 5 value is 0.4. Now you take z transform on both sides. Before that you send this z to RHS side. By sending z into RHS side, now you apply inverse z transform. Therefore you are getting z inverse of f of z is equals to 8 by 75 is constant, z inverse of z by z minus 0.2 plus 1 by 75 into z inverse of z by this z plus 0.4 can be written as z minus of 0.4. Then use these formulas. You already familiar with the formula. Z inverse of z by z minus a can be written as a power n. So therefore here it is in the same pattern, z by z minus a. Therefore a value is 0.4. Inverse z transform of this is 0.2 power n. In the same way here in place of a you are having minus 0.4. Therefore inverse z transform of this is minus 0.4 power n. Okay. So this is the inverse z transform for the given expression. Okay. So now let us proceed with the next example in the next video. Thank you.